technical.
Okay,
Don't waste time.
okay,
Just start
Kiran.
the technical.
Yeah, we are going to start without wasting a time.
Yeah.
Okay. So, Kamlesh brother.
Okay. So let's just
So, guys,
yes,
before
yes, yes.
starting that, I will say something like, since questions are too many, so we'll go with the normal pace. If it will not be covered today, we'll cover in next meeting. Okay, Kamlesh bro.
What did you just said last? I couldn't
That
hear you.
if we will not able to cover the all questions, we will cover in next meetings,
Yeah,
next.
sure,
Okay.
sure, sure.
Okay.
Okay. So let's just start with RAC, refrigeration air conditioning. Okay. Uh, So first question is explain VCRS and components and TS and pH diagram. And
Okay. Who is going
hello.
to explain first? Anyone?
Can I?
Yeah,
Yeah, sure.
sure.
So basically, vapor compression cycle consists of the main four component. First component is the compressor, then condenser, then thermostatic expansion valve, and last one is evaporator. So the cycle starts from compressor. So during the compression suction stroke, the low temperature, low pressure, dry saturated vapor refrigerant drawn from the evaporator and compressor compresses it and converted into the high pressure, high temperature, superheated vapor refrigerant and then supplied towards the condenser. So basically inside the condenser, the condensation takes place. That means the vapor state is converted into the liquid state. So inside the condenser, the condensation happen with the help of Fourier law of condensation. So inside the condenser, the refrigerant rejects heat and then heat is given to the cooling medium or the any type of cooling medium, that is water, atmospheric air, and then at the end of condenser, the high pressure, high temperature refrigerant is converted into the high pressure, medium temperature liquid refrigerant. It may be saturated liquid refrigerant, and then this is supplied toward the thermostatic expansion valve. So basically thermostatic expansion valve acts as a throttling device. So thermostatic expansion valve just regulates the flow of refrigerant according to the load on system. So basically inside thermostatic expansion valve, the small opening like orifice plate is created over there. So when the liquid is passed to that small opening, its velocity increases. That reduces the pressure. So we know that when sudden drop in pressure also, that reduces the temperature also. So because of the according to Gay Lussac's law, when the pressure reduces, temperature also reduces. So at the end of thermostatic expansion valve, the high pressure, medium temperature liquid refrigerant is converted into the low pressure, low pressure, lowest temperature liquid plus vapor mixture, and then it is supplied towards the evaporator. So inside the evaporator is place where the space is to be cooled. So inside the evaporator, refrigerant absorb considerable amount of heat and convert it into the vapor state. So the evaporation takes place according to Dalton's law of partial pressure, and the cycle remains continued. So this is basically this is a vapor compression cycle. Also, there is a sensing bulb is fitted over there, and it is connected to the thermostatic expansion valve with the help of capillary tube. So refrigerant flows in a system is same like refrigerant flow in the capillary tube and that sensing bulb over there. So sensing bulb act according to the temperature at the end of the evaporator, temperature of refrigerant at the end of evaporator, and then direct action taken on the thermostatic expansion valve to open or to close the valve. So basically, it is all about the vapor compression cycle.
Yeah, that was a good explanation. I just had one doubt. Uh, you just said the Gay Lussac's law is applicable in TEV, right? You're on mute, Kiran.
Yes.
Huh.
It is also be
Yeah.
applicable and not applicable. I give second explanation also. So second explanation
No,
is like
just I just had one doubt. In Gay Lussac's law,
yes,
volume is constant.
yes.
but in throttling system, there is free expansion basically, right?
Free expansion.
Yeah. So
So it states
is
that
that applicable here? Because I couldn't figure it out.
because we know that when the volume of a liquid, so at the so
Mhm.
before the thermostatic expansion valve, we have the liquid state. So
Yes.
after the after the thermostatic expansion valve, we have the liquid plus vapor state. That means the volume remains constant. So if the quantity at the before the thermostatic expansion valve is 100, so at the end of thermostatic expansion valve, the quantity must be 100. That means the volume is constant over there.
Mhm. All right.
So basically, some part of liquid is converted into the vapor. Means the volume doesn't change.
Okay. I guess I'm not sure about that. I just have to check it again. Okay.
I
Yes.
have doubt.
And another question. Yeah, sure.
Okay. Why he mentioned Gay Lussac law and Dalton's law? Is I don't think so. It is necessary to mention. Rather, saying that
Yeah.
throttling
Either.
process is an isenthalpic process where sudden pressure changes, sudden pressure and temperature changes due to this process. Isenthalpic process is irreversible process. Yeah.
Yes.
So
Sudden,
interview needs
sudden
that how the pressure, how the temperature reduces after the pressure. So you have to explain that how the temperature is reduces.
we
Ask.
never
It may be
heard
cross
of
question.
application of Gay Lussac law because these
Yeah. Exactly.
gases law are for ideal gases only, and refrigerant is not considered to be an ideal gas.
You should avoid that
That's
basic
what I
part
am
in it.
saying. Like if we mention when at the time of interview, maybe we can be cross questions that how you are mentioning this law, this gases law, because this gases law are applicable for a prior assumption that gases should be ideal gas. Am I correct or not? Is my questioning
Yes,
is
you are
correct or not? Yeah.
Correct.
And I also never heard that and Fourier law. To be honest, I don't know what Dalton's law and
No,
Fourier law of condensation is.
So the Fourier law means the so Fourier
yes,
law states that the no,
go ahead.
can I explain for you? So
I'm saying that
basically, no, Harshit
uh,
has the same something.
Yes,
Okay,
Harshit.
Harshit.
I was saying that there was no need to explain the sensing bulb. Like the question was about a VCRS cycle. I think you should end it by saying to about the sensing bulb to make the explanation complete.
Yeah, you are
Am I
not
audible?
audible, bro.
Yeah, just
Your voice is so. Can
can't
you
hear you
loud up
clearly.
your voice little bit? Harshit there?
I want to ask you that. So can you explain the thermostat expansion mode?
Am I
So
audible to
what
you
No,
is
guys
the
now?
thermostat
no.
expansion?
The explanation was right. It's just my doubt that if Gay Lussac's law applicable there because
So
volume
I
isn't
also a
constant in
second.
that case. It
So I
expands.
also a second explanation in that. I have two explanations.
Yeah.
So first, second explanation is like so when the liquid if passes to the so when the velocity of liquid is increases because of that liquid refrigerant passing through a small hole, that reduces the
Yeah.
pressure also, you know that. And lower pressure means the lower temperature, lower pressure means the lower boiling point. So liquid starts boils. So some part of liquid after the boiling, some part of liquid is converted into the vapor, and because of that evaporation, the cooling effect it takes place
Yes.
on that remaining
Right. Right.
refrigerant. That is also second reason. But I have heard somewhere that the interviewer sorry just because of the Gay
Yeah.
Lussac law. So he want to just
Yeah. The second explanation it's more convincing for me because I have heard that before as well, and that
I also
makes
have
sense
heard that.
to me because
So we know
most
that
of
the
the heat is
evaporation, yes, yes.
utilized to get converted as a since latent heat to get
Yes,
converted
latent
into
heat.
the liquid form.
So we know that after
Okay.
evaporation gives the cooling effect. So
Yes.
that is also reduction of the temperature also.
Okay. So I have another doubt. Why do we exactly use compressor?
A compressor used to increase the pressure. We know that
Yeah, but why?
Throttling is not happen na. We have to reduces the velocity, increases the velocity to reduce the pressure. So
Can I
if the
guess it?
pressure is not high, so how can we get velocity?
Basically,
Can I
compressor
give
Can
is
I
my
used
guess
to
it?
maintain the flow
Sir, can I give my view
so
on that?
that the refrigerant can
Also, the
flow through
compressor
the
used to
system.
convert the superheated steam.
Can I guess it?
Hello.
Hello?
Yeah.
Yes.
Okay,
Okay.
just one by one by one.
as
Yeah.
as we know that the 1 liter of water is equal to 1750 liter of gases in
Steam. Yes.
steam. That much big
Yes.
volume. If we don't use compressor, we have to use the system can be so much larger for storing that volume of steam, because I
We
am
are expanding it anyway, na, in evaporator. We are
Hello?
expanding it.
Sir, can I give
Basically,
Can
my
I
view
so
on that?
can I
Yeah.
answer?
Yeah.
okay.
Who's
Basically,
yes,
compressor in the refrigeration system is basically used to maintain the flow of the refrigerant throughout the system. Because if like there will be no compressor, then the refrigerant will not be able to flow.
okay? Anyone else?
It basically maintains the flow.
can
Anyone
I
else?
explain again?
So can I give my view or no?
Yeah, sure.
Yeah, you can speak.
Yes, okay. So I think that the compressor is there to change the vapor refrigerant into the liquid phase. I think that's the answer. And to change the state from vapor to the liquid, pressure is to be applied and also the cooling is to be applied. So that's why for applying the pressure, we need a compressor over there.
Yeah. Okay. So basically, our refrigeration की जो basic idea है, it's absorb heat at low pressure and reject it at higher pressure. So that's why we are using the compressor. If we are using it every entire system is at same pressure, no, then you have to go against the heat transfer law.
I didn't get
Getting
it.
any
Yeah,
sense?
can you explain once again? Like,
Yes.
Okay. So let's assume you have removed the compressor and entire system is running at same pressure.
okay.
Okay, so same pressure, there won't be any temperature difference. But you have to remove heat from colder area and reject it to the hotter sink. Right? Okay, in condenser. Okay, so for that you have to go against the heat transfer law, which says heat transfers from hot to cold body.
Higher temperature, lower temperature. Okay.
So yeah, so to tackle that part, we absorb the heat at low pressure and reject it at high pressure.
No,
I have
basically, I
also one
also
explanation.
have studied about compressor.
And also it maintains the flow, right?
So the main purpose is only to maintain the flow only. Because
Okay.
because the compressor is basically responsible for creating the pressure difference. That's why the refrigerant keeps on flowing through all the components.
Okay.
The compressor don't play any like role in heat extracted or removed.
No, it's there to create the pressure difference so that we can extract and
main-
remove the heat.
Yes, the main purpose of the compressor is this only, to keep
Yeah,
the refrigerant flowing throughout the system. If like
We will
We can
research on
agree on.
that. We'll search and post answer.
Yeah.
Let's go ahead with the next question. TS and
Okay.
TS. Okay. Kamlesh, go
So
ahead.
pH and TS diagram. Do you want to discuss it?
Let's discuss this much only. What is the process of just like thermostatic expansion valve process isenthalpic? Which process is compression? Anyone?
Isentropic compression is there.
Isentropic compressor
And
is
the
there.
constant pressure. Yes.
Or
constant
that
pressure, heat rejection, and heat absorption.
I have one the doubt in this diagram TS. That why the expansion process, why it is not coming straightly down, why it is going towards towards the right little bit. That is why entropy is increasing.
I can say then, sir.
Only in the
Yeah, sure.
yes, and
So basically, is that the at whenever the state of the after condensation, the state of the liquid is refrigerant is saturated liquid. If we put the if we put the isentropic expansion, there is required a turbine, so that at the inlet of the turbine will be a saturated liquid, so there will be chances of corrosion, and also there is a expansion work is very less as compared to the compression work. And we know that open system, in case of open system, compression work is v into dp. Here is the v specific volume is saturated liquid, and it is very less as compared to saturated vapor. And in the compressor, the compressor at the inlet of the compressor saturated vapor, and saturated vapor is very higher as compared to the saturated liquid. That's why expansion work is very less as compared to compression work. There will be no change in work input. That's why we put the thermostatic expansion valve in place of expansion valve, the isenthalpy expansion. And also cost of the system also very less if we put thermostatic expansion valve. I think this will be enough for
Yes,
me.
so Somnath, I
Can I
think
explain
you
it?
just explain why
Yes.
we use thermostatic expansion valve instead of turbine, right?
Yes, in yes. Work done will be work done also. Compression work done also work into little bit decreases.
Mhm.
Yeah.
Okay.
Okay.
and
Even
someone explain in more simple way. Anyone
yeah,
Okay.
knows
because
better.
it just went straight over my head.
Yes, same.
Somnath,
Yes,
would
yes.
you please type it in the group later after the meeting so
Later.
that
Okay.
we could read it and process it?
Okay.
Okay.
So, thank you. Okay, so
The
anyone else
a
got
simple
explanation?
explanation I got for this is that
Mhm.
the this expansion which is happening is a irreversible process.
Okay.
So that's why the entropy is little bit increased, but I don't know the exact explanation for this. That much I found that it is a irreversible process.
Mhm. So don't have the
Isentro-
exact answer for that. I think
what was the basic question? What was the main question?
The question was
I
that
think
when after the condenser, why the in TS diagram, why the line is not coming down? Because in expansion wall, the temperature is reducing now.
Yeah, temperature is reducing.
he's
So it
asking
is
about
going
this part,
somewhat towards the
right,
uh,
Gurvinder?
3 to 4.
No, no, you asked
3
about
to 4
3 to 4.
expansion.
3 to 4.
This portion,
expansion.
this portion.
So he says that the why the line is
Expansion.
not straight. It is why
Okay,
inclined,
okay.
inclined or cross.
Why it is increasing entropy?
See, I have written here also. Throttling process from 3 to 4 is shown in dotted line because it is highly irreversible. Someone is saying also. I think Kiran was saying. Because of high reversible process, we cannot plot the exact traces of the graph, like exact traces that the uniformity in graph. That's why I represent as a dot.
Okay.
So reason is this only because of its highly irreversible nature. It is represented as a dotted line. I think it is here we can conclude it.
Okay. All right. So should we move to the next one?
Yeah.
I just lost the question. Okay. Uh, which part of in the VCRS system actually cools the refrigerant? I mean,
Evaporator.
exactly at which part
I
the
think
temperature is reducing.
I think it's the
Thermostatic
condenser.
expansion valve.
Temperature of the refrigerant is reducing.
I
Thermostatic
think this is
expansion.
condenser.
Thermostatic.
Condenser.
Kamlesh, can you
With
repeat the
the
question?
Condenser.
Sorry, Harshit, I can't hear you.
Can you repeat the question?
The question is, in which part the temperature of uh, refrigerant
Refrigerant
reduces in VCRS?
reduces. So it is a thermostatic expansion valve.
No, I think this is a condenser. Condenser first. There is a constant pressure heat rejection takes place.
Then
So
after
that's
I think
why
I think
temperature.
in both the condenser and the expansion valve, there's a reduction in the
Yes,
temperature.
yes, yes. In
First
both
inside
cases,
the
there is
so
reduction in temperature.
so just
And
see the TS diagram. Inside you know that after the condenser, very little amount of temperature decreases. But after the expansion or after the thermostatic expansion, or there is a sudden drop in the temperature.
Yeah.
Because of the sudden drop in pressure.
correct.
So the thermostatic expansion valve reduces the temperature.
The actual
yeah,
cooling effect is made by only thermostatic expansion valve, not by
right.
the evaporator.
Yes,
Oh,
yes,
sorry,
yes.
condenser.
Condenser.
Yes,
Yeah,
yes,
right, right.
yes, yes.
In actually,
Just see
in
the
condenser
TS diagram.
also temperature drops, but in sense of this question, the right answer is T.
Thermostatic expansion. So you can
Yeah.
also say the both condenser and thermostatic expansion. It is also correct.
Yeah.
According to me.
Exactly. Yeah, but in thermostatic expansion, there is significant decrease, and that's actually provides the cooling effect.
Okay,
Yes.
okay.
Okay, so next question is effects of superheat and subcooling on the entire COP or cooling effect.
I think because of the superheating of the refrigerant, refrigerating capacity is decreased, and because of the subcooling, our refrigeration capacity is increased.
Okay, then why we want why the superheat is desirable if the refrigerating capacity is decreasing?
Can I say this answer? Or
Can you repeat?
if someone first.
Kamlesh, can you repeat the question?
Okay, so it's desirable
Kamlesh,
to
can you
have
repeat the
some
question?
amount of superheat. So if it is decreasing the performance, then why we want it?
To ensure
It's
that
like
to ensure that no amount of liquid refrigerant is going to the compressor, because
Correct.
the liquid refrigerant can damage
Correct.
it.
Correct, correct.
Right. Okay. So anyone else would like to add anything?
And
Apart from
superheating
this
also increases refrigeration effect.
No,
Yeah,
sir,
up
it
to
decreases
certain
the
extent.
superheating
Up to
is
certain
decreasing the refrigeration effect.
No, it doesn't increase. It is just for the safety purpose for the compressor.
Okay.
Yes, we can also say that safety purpose.
No.
Yeah, but
See,
if it is too much,
superheating. Correct. Let me correct it. Now I get it. Superheating also increases work input and also increases refrigeration effect. So it will depend on the quality of refrigerant that the refrigeration capacity are going to increase or not. Because as we see, the coefficient of performance formula is refrigeration effect upon work input. In this case, both refrigeration effect is also increasing because of superheating, and work input is also increasing.
No, I think you should not mention about when we are talking about superheat. You should never mention that the refrigerating capacity is increasing.
Yes, yes.
You should never mention that.
yeah, I think there is very slight increase, but I'm not sure about it. But if
Yeah.
the degree of superheat is too much, then it will add up the compressor work. That's why we just maintained around 5 to 20 degrees, 5 to 10 or 20 degrees,
5 to 7.
7
5
to
to
5
8.
to 70.
5 to 8.
I have graph also that is showing that
That's the
refrigeration
Euler's chart.
effect is increasing. Anyway,
No, it's Euler's chart in which the superheat decreases the refrigerating capacity. You'll just see it clearly
Yes,
in Euler's
yes.
chart.
In Euler's
Effect
chart,
of-
the superheat decreases the refrigeration capacity, whereas the subcooling increases the refrigeration capacity.
Increases the yeah.
Yes, right.
Definitely.
Okay. So
Yeah, you can check again if you have
Okay.
time.
yeah.
What you
you
people
found
just said,
successful.
subcooling increases refrigeration capacity
Yes.
and superheating
Yes.
decreases refrigeration capacity. I will cross check
Yes, sir.
and
Yes, yes.
okay and revert. Okay.
Just check the Mollis chart. You will get a good idea.
Don't also check
Fourier
it. You
chart.
can watch the video.
Because I was also finding in Dreamer
You can
lecture,
do the
sir has
video.
see guys, listen. There was a discussion between sir and me also on this thing, refrigeration capacity. That is in Dreamer package. He taught something which I felt with my
Yes,
my
yes,
college
Mollis chart.
teacher was not coincident. He taught something like little concept wrong in there. I think let me RAC. I
Which
have also
concept?
discussed
Mollis
with
chart.
Preet sir. Maybe this is the refrigeration capacity we are talking about, but I will revert after. Here in Dreamer package, sir has also told that
Yes,
subcooling
please.
increases refrigeration capacity and superheating decreases.
Hmm.
So there I had
Hmm.
also some doubt, and I discussed with Prince sir itself when I was working with him. So I will revert. I will revert and clarify it with my logic, because in my college notes from where I have learned, it is different. Okay. Okay, we can go on with next question.
Desirable properties of refrigerant.
Okay.
Low boiling point, low condensing temperature. Sorry, low
Hmm?
boiling point, low condensing pressure. Cheap. It should be cheap, and it should be non-flammable, non-toxic, non-corrosive, and it should have a higher critical point. It should be miscible with the oil, and it should have a low global warming potential and also low ozone layer depletion potential.
And it should not
Yeah, I think
miscible
that's
with oil.
sufficient.
I think
It
it
should
should be
be.
miscible with oil. It should
It
be
should
miscible
be
with oil.
miscible.
It should
So
have
you
high
can get the
latent
oil
heat
back.
of evaporation.
Not be
Yeah,
miscible with
that
oil, na?
That's one of the important points.
No,
It
no.
should be
I
low.
It should
also
have
got
very
Sorry.
high
confused with the
latent
miscible
heat of
oil.
evaporation. Because of that only we will get a better
yes,
cooling
Yes,
effect.
yes,
yes, yes,
yes.
yes.
High
You are right.
latent heat should be there.
Yes,
Yes,
yes.
Hmm.
yes.
And
The one we are
it
talking
should
about,
have
na, that the
also low
miscible oil.
viscosity.
I have never heard of
Yes.
miscibility. What you
It
people are
should be
saying?
miscible because
It should
Yes,
be
yes.
yes, it should be.
basically mixed
Because
with
fast
the oil
lubrication takes
properly
place in
so
the
that it can
compressor.
come back to the compressor.
Yes, yes.
Compressor will have proper lubrication.
And there are
That's why it
chances
should be
that some
miscible with
oil
oil.
can go into the go and mix with the refrigerant, so we can get
Yes,
back the oil. So
Yes,
that's
yes.
why it should be miscible with the oil.
Because oil is
yes,
a
right.
insulator, na? It will not allow the heat transfer
Yes,
properly.
yes.
That's
It
why
should
it
not
should come
miscible with
back to.
oil, na?
No, in
Should
IC
be.
engine we use that for cooling also oil.
Kiran, I was also confused with this. Then I
So
just
I have
searched
written
with it.
that. Yes.
It
So,
should
sorry,
be.
sorry, sir. I have
It
written
should
that.
be
Can I
miscible.
explain it? It should not be miscible,
Yes, yes.
because if it
No, no.
miscible
It
with
should
oil,
be miscible.
no, no. Can I explain it?
Yes.
Yeah.
Okay, okay. So
Go
tell
ahead.
me.
So if it is miscible with oil and goes in a evaporator, so it acts as an insulator. So it doesn't take the proper amount of heat from the evaporator,
No, no,
and
no, no,
that
sir.
causes the decreasing in the capacity of the evaporator.
Sir, if the refrigerant will not be miscible with oil, then this can happen. But if the
Yes.
refrigerant is miscible,
I
then
also
this
have
cannot
like one
happen.
explanation
I
with
Oil
this
also
will
know that.
definition.
Hello.
That
Can I
if
say
sometimes the
something?
oil gets mixed with the refrigerant, na. So if it is not miscible, if it will just stay inside the system, somewhere in the system only. So it will never come back to the compressor. That's why it should be miscible. That and like if it gets in the system, the refrigerant gets mixed with the oil, and when it comes to back to compressor, it can be separated out with the oil separator that we put after the compressor.
Yeah. So let's just
Can I
Which
say
are the
something?
common
everyone.
refrigerant we use?
Yeah.
Hello.
R134A on the chips.
Can I? I am audible.
Yeah.
Yes, yes.
I know some refrigerant which are fully miscible with oil, like as R11 and R12, and some refrigerant which are fully immiscible, like NH3 and CO2, and
That's
some
why they are
refrigerant which are
it's
partially
not
miscible
mm.
in R22. I think partially miscible is not required. Fully miscible is also can be work, and fully immiscible can also be work. Partially miscible is not
I
required
have
in the
just
refer
written
system.
that mixing of oil with the refrigerant losses the heat transfer capacity. So
Also
when it
valid
goes to
point.
the evaporator, so if it goes to the evaporator, it acts as an insulator. So
Yes,
oil
yes,
acts as an
insulator.
insulator. So it acts as an insulator.
Yes, yes.
So if it acts as an insulator inside the evaporation, the cooling is not getting proper. So we know that the heat
Okay,
always
okay.
transfer from higher temperature to lower temperature. And if the oil is get trapped in between, so there is a no proper heat transfer is taken place. So it acts
Okay,
as an
okay.
insulator.
Okay,
So we
I
have
can
to remove that oil. So after the compressor, we just apply over the oil oily separator over here.
Rectifier,
if
something
like the
called dryer,
if like the
something called
if like sometimes
rectifier or dryer,
oil
something.
is oil is in
Yeah,
the
dryer
evaporator,
is there also.
how
Dryer
will you
is
remove it?
used to remove the moisture.
Actually, I have also read it somewhere that it should be miscible, and there is dryer
Student,
also there,
student,
which
I have one
works.
question.
Yeah, sure.
Hello.
Yes, yes, sure, yes.
Like if like the oil gets in the evaporator, so how it will come back
Yeah,
if
it will be
it
just
stays
stayed
there?
there, no?
It
If it's
Well,
not
it
will
is
miscible.
there, na?
keep on staying there. Yes,
It
you are
is
saying
there.
that it should not be miscible, which means that it will not mix with the refrigerant gas, so it will stay there. So how it will come to the compressor?
And
I
if
Good
think we
point.
need
Good
some
point.
expert
while
advice on that
in
part.
coming with in compressor, it should be in gaseous form. Otherwise, it can be it can damage compressor.
Good point. I will note down.
I
So
think we just need
so
some
that's why
some expert
so
to
that's
answer
why
this
we
That's
question.
why discussion is
uh,
important. Okay.
so that's why we use the refrigerant which should be miscible. Like if
It
sometimes
should.
oil goes into the system,
Mhm.
so it should come back to the compressor. So after the compressor, it can be removed.
Okay.
Bro, how it will be removed?
By
Can
the
you
oil
answer
separator.
that?
He means
For the
there
oil
won't be
separator.
any
See,
clogging. It
I
will
have
come
read
always
somewhere
come
that
back to the
It will be
compressor.
removed
after
with
the
the oil
compressor
separator.
process, there is a
Oil
oil water
separator is there.
separator. Yeah,
Yes,
there is a
Yes.
yes.
separator.
Water separator.
So
Yes.
After
it
the
will be
compressor.
removed after the process only, within the compressor only.
Yes.
So we don't have
But
to much worry about it.
if sometimes it flows, we are saying na, if it can be some
Then
time it will
it will
flow to the
come back
system.
back into the compressor, and it may cause a problem, because there can be explosion, because when the piston will compress the oil, at that time explosion can happen. So oil filter that is present after the compressor is used to remove the oil. At that time only oils are get removed, so we don't have to, I think, much worry about it.
Mm.
I think
Are you getting it?
Someone
further
just said
question.
like there are some just someone who I think someone just said there are some refrigerant which are miscible and which are not. Both are
Both
I think
can
used.
it
work.
should not be miscible. It should not miscible,
Okay, just if anyone found
according to
any
me,
No, it should
but
be
uh
miscible
I'm not sure
according
about
to
it.
me. But I studied in the trimmers package what I am explaining. But that's all.
yeah, because I also remember reading it somewhere that it
So
should be
here is also
miscible.
the
if
conflict
But if
about
it will
anyone
be
that
found
miscible,
point. I will note it and I will
yeah,
let you
yeah,
know.
just let's just
Okay.
try to find more about that and let's just
I
move
will
on to
note.
the next question.
I
Otherwise,
will
we'll
note
just
that point.
stuck
I will note
here.
that.
it's a
Yep.
good
Yes,
point.
yes.
Okay.
Really.
So go ahead.
So
Go ahead.
where was
I think we should avoid saying this property in the interview.
Exactly.
Yes,
okay,
best
okay,
solution. Best
better
solution.
option.
That's the better way
Actually,
Okay,
at the
get
time
out
of
of it.
cross questioning, we will be in trouble.
Best
okay, so
solution.
So,
just
so
We can conclude that
we are just
we don't
running
have
out
to
of
say
time.
this
that
now.
is the
It's just
best
2
explanation.
minutes
Yeah.
30 seconds.
Before the
Hello.
I will putting another meeting. Just it will take I think 5-minute gap,
Yeah.
5 to
Let's
7
just
minute gap. Any short
Yeah,
question you are
okay,
having?
let's just sign
I
out.
think all our questions covered or not?
No, it's
Not.
not.
No, actually, in RAC there are 2-3 questions remaining,
Okay.
and electrical part is completely left out. We
Okay.
haven't even touched it.
Guys,
So you guys,
Kamlesh
what
bro,
to do?
I have one question. Which refrigerant we use on board ship to in meat room or in fish room to?
Yeah. So according to older standards, we use R22 and R12, but now it's R123A.
R1
I think in most of the
123A.
ships,
134A.
R134 is used.
Can I explain it?
Yeah.
Kamlesh,
Yeah.
Kamlesh, can you say
So
once more
according
which
to the
refrigerant
according to the MARPOL from 2022,
Mhm.
MARPOL releases guideline that on ship you have to use only HFCs, that is hydrofluorocarbon, from 2022. So
Okay.
the refrigerant come under the hydrofluorocarbons are R134A, R404A, R407A,
C.
R507A, and R22A,
R407C it is.
R407C.
Yes.
And
So see,
R410A also. 410A.
410A.
These are most
There is
commonly used.
prohibition in
410A
CF
and
using of.
134.
Okay. There
Yeah.
is prohibition of using CFCs according to MARPOL, I think.
Yes.
Okay.
But it should be like controlled. Like we should like always keep a
If
record how much we are using, where we are using.
if you already have it, then you can
Or if already in the
continue your
system
next
we
refill.
have to continue with it because we cannot like leak it in the atmosphere.
Guys, in written exam, this formula R134A, there is certain chemical name for every these codes. That can come or not.
Yes.
Yeah.
I
That
don't
can
Yes,
come.
remember
yes,
seeing it.
Yes, it can come. It can come.
this yes, it can
Might
it can come.
be.
Okay.
No, when I
You
gave the
have to
exam,
remember
the
this
option was there.
chemical formulas.
Okay.